A third degree polynomial is like a quadratic
Mm-hmm.
equation. How would the quadratic be horizontal to the x-axis if it's always changing?
Because there are places on the function where the tangents could be horizontal, right? Like for example, this right here. So I mean that's what you're looking at. We've got a cubic polynomial, but cubic polynomials, if I just graph one in general, does everybody understand the question Zoe asked? She's a cubic. She recognized that a cubic polynomial looks something like maybe like this, right? And the derivative of that is going to be, we know that if you take a derivative of a cubic polynomial, it's going to move it, it's going to ratchet it down one order in the polynomial spectrum, right? So it's going to go from cubic to quadratic. So it's going to be a parabola. How does that work? Well, here's how. Where are the places on this function where the tangent lines are horizontal? Okay, so peaks and valleys, right? Okay, now here's the thing. What's the hallmark of a horizontal tangent? What do you know about something? What do you know is going on when there's a horizontal tangent to occur? Slope is zero. So the derivative function has a value of zero, right? Okay, so then we know that right here, there's got to be a zero of the first derivative, and right here, there's got to be a zero of the derivative, right? So if we wanted to sketch this parabola, then we could do it. What can you tell me about the slopes leading up to this horizontal tangent? Like right here, the slope is very what? Large and positive, less large and positive, small and positive, right?
Yeah.
So that's looking something like, if I were to graph those values, isn't it looking something like that? Okay. Over here, same thing, right? Small and positive, bigger and positive, large and positive. What about in between? Well, small and negative, larger and negative. There's the biggest negative value we get, right? And then it starts to get less negative again, right? So that's going to correspond to the minimum of the parabola, isn't it? That's going to be the smallest value. So it's going to do something like, I mean, I didn't draw it very well, but you get the idea, right? Okay, do we have to do something that complicated? No. We don't need to know what the whole function looks like. All we want to know here is where are the horizontal tangents. That's it, right? What x values? Where are they? So how could I set this thing up? So you already told me that horizontal tangents correspond to derivatives with a value of zero, right? What am I going to do? Set what equal to zero? Not the function, the derivative. Now I want you to see that the zeros of the function are different than the zeros of the derivative. If we take the black function that I graphed up here, how many zeros does it have?
3.
No? Only got one right there. Right? What is a zero? A zero of a function is just the x value, if we have x's, the value of x where the function has a y value of 0. In other words, where it crosses the x-axis, right? Make sense? Okay, so yeah, if I just set this function equal to 0, I'm getting back a different x value than I do if I set the derivative function equal to 0. If I set the derivative function equal to 0 and solve that equation, it's telling me the x values where I get those horizontal tangents, right? You see the logic? So if I want to find the horizontal tangents, we recognize that that means that's where y prime is equal to 0. So all we're going to do to get those answers back from the math gods is ask them the question, where does y prime equal 0? First I have to find y prime though. What's y prime?
3x squared.
Okay, there it is. So I'm just going to set that function equal to 0 and solve. Okay, that's why it's a graphing utility test. You can use your graphing utility to find those. And what do we get? Well, I don't know.
8/3 and 4.
8/3 and 4. Okay.
Can you just like plug in that original?
No. Oh, okay. So could you have plugged in the original one? I mean,
No.
yeah, if you know how to use your calculator really well, you could. There's some ways that you probably could trick the calculator into giving you the answer, but
Don't do those ways.
don't do those ways, yeah.
Yeah.
So we're gonna solve this, and we get x equals, what was it again, 8/3 or 4. Okay, so those are the places where the function has horizontal tangents. Did they want to know? Let me go back to the question. Get a little more specific here. They want to know just the x values. That's it. Okay, so we
But if you had
can.
to do the lines.
Oh, they want the equation.
Wait, wouldn't that just be?
No, they just want to know for what values of x does this function have horizontal tangents. So it's just going to be 8/3.
What if they wanted the equation of this?
If they wanted the equation, then we've got. Well, then it's just going to be whatever y equals, right?
So you just have to plug back x back in and find.
Yeah.
Wait,
Okay, so now let me make sure we understand the question. The question was, what if they instead asked, what are the equations of the horizontal tangents? Well, horizontal tangents, the equations are pretty simple. What's the equation of a horizontal line before we can get started?
Y equals a constant.
Y equals a constant, right? Whatever the y-intercept is, correct? So all we'd have to know then is once I knew what the x values were, I could just plug those in and find the corresponding y values, right? Does that make sense?
But you still have two answers?
I would have two answers, yeah. If we look on our picture, here's what they would look like, right? If I graph, I'm going to graph, one of these is going to be green. So if I graph this horizontal tangent as a green line, it's just, the equation is just y equals whatever that value is, right?
Mm-hmm.
Okay? In other words, that's the same value as the point, right? The point of
So
tangency.
plug it into the original.
Into the original equation, exactly. And then down here, we get a different one, right? Whatever the coordinates are of that point, the y value names the horizontal line, doesn't it?
Yeah.
That's not what was asked though, right? I mean, but if it were, that's how we would do it.
one does ask that.
Oh, does it? Okay, but I think it doesn't ask for a horizontal tangent,
Wait, what do you
right?
plug into the original?
I
Yeah.
don't know, okay.
We'll get to it, yeah.
What do you plug into the original equation?
The x values. See, all this equation, all this question wanted were those values. It asked for the x values where this function has a horizontal tangent, right? So we took the derivative and set it equal to 0 and solved for x.
So like you put 8/3 in to find the equation.
Yeah, but in this case, that's all we need, right? Okay? All right, moving on. Okay, let's see, another bad one. That was a bad one. I'm gonna do the worst ones first. Oh, this was a bad one. Let's do that one.
With the velocity and stuff? That one was a bad one.
Okay, yeah, find the equation for the line tangent to the curve at the given point. Let me copy this and make it bigger. You can't see that.
Whoa, that's too small.
You can't see that?
Okay. That's huge.
Okay, so we want to find the equation for the line tangent to the curve, right? So really all we need is a point and a slope. Well, the point is easy. We get the x value. How do I find the y value?
Plug it in.
Plug it in, sure. So x equals 1, y just equals 1 cubed plus 3 over 2 times 1, which is what, 2? So the point has coordinates 1, 2. Now we need this.
I haven't even written it.
So now we need the slope of the tangent line. But when we want to find a slope of a tangent line, that's calculus, right? What is that?
Derivative.
The derivative. That's what the derivative function gives us. The derivative function gives us back the slope of a curve, which is the very same thing as the slope of a tangent line to a curve, right? They mean the same thing at whatever value of x we choose. Well, they're giving us the x value, right? So all we have to do is evaluate the derivative function at x equals 1 to find the slope of the curve at x equals 1, which will also be the slope of the tangent line, right? So what is y prime here? Now, when I differentiate this, let me rewrite the function. So y equals x cubed plus 3 over 2x. So how am I going to approach this derivative? I just have to follow the rules. Okay, so it's a quotient rule, isn't it? Right? I've got a quotient of functions of x, and so it requires the quotient rule. Maybe we could rewrite this in a way where we wouldn't need the quotient rule. We could. We could just separate that into two, into two different terms that we could differentiate independently. It doesn't matter. Either way. How do you want to do it? Quotient rule? Okay, we'll go quotient rule. So,
Is there not one word?
so y prime equals what by the quotient rule? Good. Bottom times derivative of the top minus, very good, minus top times derivative of the bottom, which is 2, all divided by 2x quantity squared, which is actually what? 4x squared. Okay, good. So then if we simplify all this, we get what here?
6x cubed.
Okay, let's distribute the minus 2 all the way through, right? The negative 2 gets distributed and we get all over, you already told me, 4x squared, right? So do we have to spend a lot of time simplifying this?
Yep.
No. I mean, we might as well do one small step to simplify, but we didn't even really need to do that. How come?
You can just plug in x.
Because we're plugging in a value of x anyway, right? And numbers are easier to simplify than variables, right?
Doesn't it I lied. Nope.
What's that?
Nothing.
Okay.
I thought.
I wasn't listening to you anyway, so that doesn't count as a lie. I had too many people talking.
You're gonna get fired for that.
Oh, okay. All right. So x equals 1. I'm just plugging that in. I could have plugged it in here, but let's go ahead and plug it in here. It doesn't make any difference. When I plug in x equals 1, what am I going to get? 6 times 1 minus 2 times 1 is 4. Minus 6 is over 4 times 1. Right? So that's the slope of the tangent line, right?
Wait. How did you all of a sudden get negative?
Because I just plugged in, I did this. I plugged in x equals 1. There.
Sweet. Which equals 6 minus 2 minus 6.
Because we're trying to find the equation for the line, right? So we need a point and a slope.
Okay, so that's our.
Right. You got me. Okay. So then here's our information, right? We know here's the point, and the slope is negative 1/2, and we probably don't even need to spend the time finding the line, right? I mean, you guys can all find the equation of a line. So we could combine that, right? Solve for b, we know m. Okay, make sense?
Would it be, here, let's just say it out loud. Would it be y minus 2 equals negative 1/2 times x minus 1?
That's one way to do it, using point slope. Yeah. The other way to do it would just be to solve for b by saying if y equals mx plus b, we already know m, but to solve for b, I would just plug all that stuff in that I know to solve for b.
So real quick, it'd be 2 equals negative 1/2 times 1 plus b, and
Yep.
you solve for b.
Mm-hmm. Solve for b. Yep.
Wait,
And then you put that in for
Yep.
your answer.
Exactly. And then I write my answer in the form mx plus b. We're done. Yep.
So it would be 1/2.
The answer then is.
Okay.
Oh, that's 3/2.
Are we good?
no, wait. What
No.
was the answer?
Isn't it 2.5?
So, okay, so the answer is going to be, has anybody done it?
Yeah, 2.
Negative half x.
So plus 5.
That's 2.5.
Why? But we would never use a mixed number. What are we in grade school here? We're not going to use mixed numbers. Minus 1/2 x plus 5/2, right?
We're not in grade school.
So that's your final answer, that
Slope.
Evidently, yeah. Oh, okay. Yeah, that's right.
You quoted me. I said that to you 2 days ago.
Okay, another one.
So what's the other one?
here's another one. Acceleration, velocity, etc.
Okay, yeah, the velocity.
I can see it. I gotta put my glasses on.
Sorry.
Okay, so there we go. Oops.
I thought it was so short.
I can't see in Spanish, I'm like, don't think anyone can.
I was writing
Have you guys studied for that test yet?
Is that okay, Delaney? No problem.
I can see that.
I couldn't even, like, I couldn't even see it at what,
The position of a body.
Okay, are we ready?
Yeah.
All right.
Write it down.
Okay,
I
so
remember this. I wrote this down about 6
this is
years
a very good problem. I really like this one.
Ew, we hate it.
No, you don't
You
need it.
speak for everybody.
Okay. The position of a body at time t is given to us. Here's our position function, right?
Uh-huh.
S is our position function. Find the body's acceleration each time the velocity is 0, right?
Yep.
Okay, this is not a difficult question, but you have to be able to understand kind of what they're asking a little bit, which is why it's a good question.
Uh-huh.
The math is not hard. So let's write down, here's our position function, which I'm going to write as S of t. Okay, so how am I going to find velocity? How is velocity related to position? Derivative. Okay, good. So v
Oh,
of t is just s prime of t, which is what?
negative
Oh, and then
3t
you said it's
squared
equal to 0.
Ah, okay, negative 3t squared.
Plus 24t.
Okay, so when you're doing a problem like this, doesn't it make sense probably analytically here to write down the functions that you're going to use? So we have position, we're going to need velocity and acceleration. But what's acceleration?
A.
A, okay, but how do we find A?
Derivative of velocity.
Okay, derivative of velocity, which is the,
Y squared. Y squared.
Y prime.
Y prime 2 times.
okay, so it's the second derivative of position, right. So A of t
Find the derivative.
equals v prime of t,
Or S prime prime.
or s double prime of t, which is what? Okay, so now we've got all the pieces that we need to do the analysis. So we want to find the body's acceleration, but we need to know each time the velocity is 0. Okay, so when they say each time the velocity is 0, they mean the values of t, right?
Sure do.
So how am I going to do that?
Plug 0 into v.
Good, set it equal to 0, right? I'm going to set velocity equal to 0 and solve. So that's going to give me negative 3t squared plus 24t minus 36 equals 0. We can do that one easily. What would I do? Let's do the algebra real quick.
Okay. Wait. Don't we put this in our calculator?
No, we don't need our calculators for this one.
But
What-
because
what are
we
we gonna-
take out a 3.
Okay, we're going to divide both sides by negative 3, right? Everybody agree?
Yeah.
Sure are.
That's going to give me t squared Okay, so how does that factor?
Okay. I don't know. I hate
6 and 2.
Good. Signs.
Negative.
Yeah.
So my solutions are t
2 and
equals,
6 and 2.
okay, 2 and 6, good.
Can you guys please keep it
So
down?
what would that be?
Okay, so now, but the question doesn't ask for those.
No.
What the question wants to know is, what is the acceleration each time the velocity is 0? So we got to take both of those instances. So let's take
Plug those into your already derivatives.
into my acceleration, right?
A of 6. A of 2. Or A of 6.
So a of 6 is negative 6 times 6 plus 24, which is negative 36 plus 24 is, no, acceleration. Yeah.
See, guys?
A of 2 is just negative 6 times 2 plus 24, which is positive 12. So those are my answers.
Is there an easier way?
Right?
This is pretty.
Okay.
I don't get how we're supposed to do it. I'm sure we've never learned this before.
Yes, you have.
We learned
Okay,
the
now do the
concept.
one where velocity is like equals 42 and then the equation is like it's
So our answer is just equal negative 12.
You don't want to know how to do that? Maybe you can raise your hand next time you do your
Okay, so the body's acceleration each time the velocity is 0 is what? They just want you to separate your answers with a comma. So positive 12, negative 12, right?
Okay, so you know that.
All right, moving on.
How do you know to choose 6 over 2? Did you say that? You do both.
You both.
That's why you said separate your answers.
Maybe you should raise your hand.
Okay, hey, listen. This is.
Reel us
This
back
is
in.
too loud. I'm having a hard time. I mean, I gotta believe some people are having a hard time getting this, right? I mean, it's, you gotta raise your hand if you want to contribute. I'd like to hear the contribution. Yes, ma'am.
Oh wait, I thought you meant like continue.
Oh, okay. So, moving on. Let's pick another one. Okay. All right.
Number 5.
Okay. I think this might be a good one. Let's look at this one.
Clear.
Oh, yeah.
Yeah. Okay. Yeah. This is good. This is good.
I remember that one. I'm pretty sure I messed that one. Yeah, 100%.
No.
Okay, so now we've got different position function, but same idea. We want to find the body's velocity, speed, and acceleration at that time, when t equals pi thirds. So they give us the position function, just like before. Now don't wig out, because this is a sine function. It's not that big a deal. It's just a function that you know how to differentiate, right? It's not the end of the world. S of t is 3 minus 5 sine t. So what is
VT.
v of t? Just the derivative, right? So what is it?
Negative 5 cos.
Negative 5 cosine t, and acceleration is then
5 sine t.
good, because the derivative of cosine is negative sine. The negatives cancel. Very good. Okay, so all we have to do then, this is easy. All we have to do is just plug in
Pi thirds.
pi thirds. Yeah, that's no big deal, right?
No.
So s of pi thirds.
Wait, what about speed?
That's
Okay.
GT.
Okay, so now how are speed and velocity
They're
related?
the same, but one is positive.
Okay, so velocity has direction, right? So velocity can be negative or positive. So the classic example here would be if I'm walking in the front of the room and that's the positive direction, if I'm covering 2 meters every second, what's my speed?
2 meters per second.
What was my velocity there? Good. Now I'm walking in the negative direction. 2 meters every second. What's my speed?
Positive.
2 meters per second is my speed, but what's my velocity?
Negative.
Negative because I'm going that way, right? That's the difference. So speed is just the absolute value of velocity.
Okay.
All right, so S of, sorry, we don't want S, we want V. So V of pi thirds is just 3 minus 5 times sine pi thirds. Now, what's the sine?
Isn't it minus 5 cosine?
Wait, that.
Oh, I'm sorry. I did, yeah, wrong function. You're right.
Hey, at least you know what I know.
Good, good. That was just a test. Minus 5 cosine pi thirds. So pi thirds is 60 degrees, right?
Sure is.
So that's this guy right here. Now, what are the coordinates on the unit circle at 60 degrees or pi thirds?
3 over, no, square root 1. 1 over 4. 1/2 square root 3 over 1.
2.
1/2.
Okay, you guys are not good at your unit circle. We're gonna have to review this. You guys- Yeah.
We've been taught the triangles.
Yeah. Yeah. Well, in fact, I think we're gonna take a second and go through that. We'll continue this tomorrow if we need to, but we need to do this. So unit circle, this is so easy. I want to show you something. This is, okay, but you guys seem to have, here's the deal. With the triangles, you seem to have problems with angles that are not between 0 and 90.
True.
Right?
No.
Okay, and that's gonna come up a lot. That's just been my observation. So let's quickly review this. This will take us 5-10 minutes, and then you'll understand, and then this will be helpful. So all you need to know to be able to populate the entire unit circle is quadrant 1, and then you're just going to reflect quadrant 1 once or twice. Okay? So let's go through this. So in quadrant 1, all we have to know are the 5 points that are in or on the edge of quadrant 1. And they're symmetrical, right? So let's take all those points and let's write down all the information that we need to for those. So we want to write down what's the angle in radians, what's the angle in degrees, and what are the coordinates of the point. So this one right here is 0 degrees, agreed?
Yeah.
0 radians, and the coordinates are
1, 0.
1, 0. Okay? This one here is at 90 degrees or pi over 2, and the coordinates are 0, 1. Okay, now let's look at these others. So this one, the one in the middle is at what?
45.
45 degrees, pi over 4, and the coordinates are square root 2 over 2, square root 2 over 2. Okay, what about this one? 30 degrees, pi over 6, and the coordinates are,
1/2.
no,
Square root 3 over 2.
square root 3 over 2,
1/2.
1/2. This guy is 60 degrees. Okay, how do you remember that? Easy. How many numbers are represented? Zeros and ones are freebies, right? Those fall at the corners at the 4 horizontal and vertical places relative to the origin, right? Those are a piece of cake. How do you get these guys? Well, think about them in order. If you think about the values of the other 3 numbers, which are just 1/2, square root of 3 over 2, and square root of 2 over 2, they have a common denominator of 2. So it's easy to place them in order, right? Wouldn't you agree that 1/2 has to be the lesser of the 3?
Yes.
And then the next would be the square root of 2 over 2, and then the square root of 3 over 2, right?
Yeah.
Okay, so you know that the big and the small always go together, and the middle goes with the middle, every time, right? You know that for this point right here, this is going to have a big x value and a small y value, so it must be the square root of 3 over 2 for the x value, and the small one, 1/2 for the y value. This guy's in the middle, so he just gets the middle one twice. This guy is only over a little bit, but he's up a lot, right? So he's going to get the small x value and the big y value, right? Okay, so it's easy to construct this first quadrant. From there, everything's a piece of cake, because from there, all we do is we're just going to reflect all these points over here, right? Now, what's that going to do to those coordinates? The x values become the opposites of quadrant 1. The y values are still positive, right?
Yeah.
Make sense? Okay, if I reflect them down here, Yeah, good. The y values become negative, the x values stay positive, right?
So,
And if I reflect them twice, they both become negative, right? So all I have to do then, finding the coordinates is a piece of cake. I just need to know what angles go where. Well, that's easy too, right? Because I have symmetry here. If this is 30 degrees, then so is that, right? So 180 minus 30 is 150, right? Well, that's obviously 45, so either 90 plus 45 or 180 minus 45 is 135, and that's 60, right? That's 60. So 180 minus 60 is 120, and I can do the same thing with radians, right? I just did it with degrees, but we can play the same game with the radians. If I go down here, well, that's 30, so that's 30, and so is that 30, right? So that's just 180 plus 30 is 210. 180 plus 45 is 225. 180 plus 60 is 240. And we know that's 270, right? You see how we're playing this? So we can fill in the whole unit circle really easily, right? All you have to know is just when you're dealing with, like if this is, for example, this would be pi minus pi over 6. So 5, 6 pi. You know 5, 6 pi, if you know where that puts you, it puts you at the quadrant 2 point that has a big negative x value and a small positive y value. So you know the coordinates. Negative square root of 3 over 2, positive 1/2, right? See how that works? So you could easily, like on a test, you could just scratch out that unit circle and fill it out if you wanted to. You may not need to, but if you needed to find the coordinates of a point that was not in quadrant 1, because those you probably are just going to know after doing this once. But these other ones, all you'd have to do is just kind of think, okay, how do I get to 240 degrees? Or same thing as saying, what's that going to be? That's thirds, that's be 4/3 pi, right? Pi plus 1/3 pi, because that's 1/3 pi. You just have to think to yourself, okay, where is that? Which point is that in quadrant 3? It's this one. It's the one with a small x value and a big y value, right? And you got it, right? Does that make sense? Sort of, kind of, maybe? Okay, that was my abbreviated version. That was pretty quick. Now let's go back and do this problem. So pi thirds is 60 degrees, so that's going to be small x, big y, right?
yeah, so 1/2.
Okay, good. So that's going to be 1/2. So negative 5/2, right? Okay, so there is that answer. What's the speed then? 5/2, absolute value, right? What about the acceleration? Well, the acceleration, a of pi thirds would just be 5 times sine of 60. Well, that's going to be the big number, right? 60 degrees is small x, big y. We want the y value. Sine is the y value, correct? Right? Cosine before sine, c before s, like x before y. So we're going to get 5 square root of 3 over 2. Okay? Questions? Okay. Can we wait just a second? Tell me when.
Those are just our answers.
Those are your answers, yeah.
Can you go through the steps again on velocity?
Velocity, yeah, all we did is we were given the position function, so we take the derivative of position to get velocity, take the derivative of velocity to get acceleration, and then we're just evaluating each of those at pi thirds to get the answers. Does that answer your question, Ellie?
Will you say it again, the velocity pi is equal to negative 5 cosine?
Right.
How do you get pi negative 5?
How did I get because the cosine of pi thirds is 1/2,
I was copying something, but I missed that.
right?
Okay.
Right, because cosine,
Oh, then negative 5 times.
yeah, exactly. There you go. Yep. Okay, moving on. See if we can get one more in here.
Gonna be pushing it.
It will be.
Push the boundaries.
Okay, I'm gonna opt for, these seem to be bad, so let's do one of these.
6. That's not just- it is. Yeah, that's easy.
It's easy? Okay.
No, up
Something on that.
Oh, no, that was a good one, never mind. This is a bad one.
Yeah, there you go.
Yeah.
Yeah,
Oh,
yeah.
well, I should have.
We only have 4 minutes, I don't know if you.
Oh, I have time, okay, I can do it.
Don't push.
Don't you just distribute and then kind of drift?
Okay, I'm gonna go fast, so watch. Okay, here we go. So I'm just differentiating this product, right?
Yeah.
Okay, so would everybody agree? I'm gonna go fast here. This is U, and this is V, right? So the derivative of that product equals U times the derivative of V. But V is a chain rule issue, right? Because V is a power of a polynomial, right? So at the outermost level, if I have to differentiate V, what's the first layer of the chain rule? Okay, good, I've got 4-hand cubed. And hand is 2x minus 3. What's the second layer of the chain rule? Derivative of 2x minus 3 is? 2. Yeah, and so we can simplify that. Now, the second part of the product rule is V, which is the quantity 2x minus 3 to the 4th times the derivative of U. Well, what's the derivative of x cubed? Done. Done with the calculus. All I have to do is just simplify a little bit. And not much. 2 times 4 is 8. So I'm going to get 8x cubed times the quantity 2x minus 3 cubed plus 3x squared times the quantity 2x minus 3 to the 4th. Now, at this point in our calculus careers, that's fine. Later on, in chapter 3, that's not going to be okay because we're going to be doing something with these that's going to require us to factor that further. But for now, that's fine.
That's our answer.
That's your answer. Yeah. Okay. So this one wasn't so evil after all, was it? Okay.
Yeah, well,
No, there's one that you didn't do.
Okay, we'll get it tomorrow.
Wait, are we not having that? Wait, can't we test?
I thought you well, you can. I thought you want to test tomorrow or you want to test Monday?
Monday.
Okay. Okay.